Hello guys, welcome to this session. Today we are going to talk about the weightability and the relative permeability. Who is concerned by this course, either you are a petroleum engineer, a drilling engineer, petrophysicist, exploration who are involved into exploration phase of the oil and gas or the mining. Also, you can be geologist, petrophysicist, or any field of engineering that is interested, or scientist that's interconnect or relate with the oil and gas and the mining. Understanding this topic will be of a vital importance if you are involved in the field, as I said, the weightability and the relative permeability of the rocks. This course is offered to you by the Bridge Training College, which aims to enhance teaching and also share the knowledge. The weightability is the preference of a solid to contact one liquid or gas, known as the weighting phase, rather than other. Due to the surface tension between a fluid and a solid, the weighting phase will tend to spread on the solid surface, and a porous solid will tend to imbibe the weighting phase, in both cases displacing the non-weighting phase. The weightability is function of the weighting angle. We are going to see it in a graph. So let's keep it. The weightability phase. Let's talk about the weighting angle. Okay, let me zoom in for you. This is it. You can see the angle alpha here, or theta. You see that we have the liquid. This is a solid. The ability of the liquid to adhere on the surface of the solid is what we call the weightability, and it is a function of three components. First of all, the surface tension between the liquid and the solid, and the strength between the molecules. Let me go back to the slide. And the angle is very determinant here. If the angle is less than 90, we have a water weight. If the angle is greater than 90 degrees, it is either oil or gas weight. We call it oil and gas weight, okay? But if the angle is 90 degrees, that is a neutral weight. So in the exploration phase, we are looking for angle equal or greater than 90 degrees. Are you getting the point? So let's continue. What are the types of weightability? We may have a water weight. A thin film of water coats the surface of the formation matrix. Characteristics of a good reservoir. A good reservoir should be water weight, so that the water will sweep the oil out of the reservoir. We can have an oil weight. Rocks imbibe the crude into the small pores. That is a bad reservoir. If you have a reservoir which is oil weight, it is not a good reservoir, because the oil will be trying to adhere on the surface of the rock. It will be difficult to produce the oil. Intermediate weight, a mixed weight system in which some surfaces or grains are water weight and others are oil weight, or a neutral weight system in which the surfaces are not strongly wet by either water or oil. The typical reservoir footprint. Here we have the phase diagram of two reservoirs. It is obvious that they are not the same. Here you can have the water curve. You see that the water curve in the first phase is shorter than that in the second phase diagram. The first phase diagram, where I will call it the point of intersection between the two curves, the oil and the water. The point of its intersection is above 60%. It's a sign of a strongly water weight reservoir. Okay, if the point of intersection between both, we call it the critical point, is less than 60, that is around 50, this is a sign of an oil weight reservoir, a bad reservoir, by the way. This is what we call the point of intersection. Let me zoom it for you. Okay, Good. Now, how to measure the weightability in the lab? In the lab, we have several measurement techniques. First of all, it can be microscopic observation. This involves the direct observation and the measurement of the weighting angle on small rock sample, either a petrographic microscopic or SEM fitted with, with an environmental stage is used. The measurements are extremely difficult and good data relies more on luck than judgment. Armored weightability measurement. This is a microscopic mean weightability of a given fluid sample. It involves the measurement of the amount of fluid spontaneously and forcibly imbibed by the rock sample. It has no validity as an absolute measurement, but is industry standard for comparing the weightability of a various rock block, of a various core blocks. The amount weightability is very important. And we also have the USBM, the US Bureau of Mines method, which is well known. This is a microscopic mean weightability of a rock to give fluid to a given fluid. It is similar to the Ammon method, but consider the workforce fluid displacement as with the Ammon method. It has no validity as an absolute measurement. The contact angle measure the weightability. The contact angle measure the weightability surface, while the Ammon and the USBM method measures the average weightability of the rock. So keep in mind that the contact angle measures the weightability of a specific surface area. The contact angle measures the weightability of a specific surface area, while the Ammon and the USBM methods measure the average weightability of the core. Let's talk about the Ammon weightability index. These are the tools that are used in the lab to measure the weightability. You have the names here. In the first step, what we have to do, we have a YouTube where we take a sample and circulate water or oil through the YouTube and go about it. We will have a video where we explain this in details, an animated video. And later on, we draw what is so-called the phase diagram with the capillary pressure curves. This is the capillary pressure draft. You can see where we have imbibition, and the drainage. Here we have the weighting index, which is drawn on a triangle, and the neutrality is here. You will see the formula of the oil index, the spontaneous oil imbibition, and the total oil imbibition. And the oil index is always CD over CA. CD stands for the spontaneous oil imbibition, and CA is the total oil imbibition. The water index is calculated as spontaneous water imbibition over total water imbibition, which is AB over AC. Where is AB? Where is AC? Where is CD? This is it here on this triangle. So after you have plotted it, you have to measure the distance between A and B and between C and D. You see that these are the corners of the triangles. Okay? It is very important, by the way. Now, let's see the USBM weightability index. USBM weightability measurement. This method is very similar to the Ammons method, but measures the work required to do the imbibition. It is usually done by centrifuge, and the weightability index W is calculated since it is a work. Is calculated from the area under the capillary pressure curves A1 and A2. If you remember, the mechanical work is termed W, and W is log A1 over A2, where A1 is the area under the drainage curve and A2 is the area under the imbibition curve. How to determine A1 and A2? Okay, let's go back to the capillary pressure curve. When you come on the capillary pressure graph here, oh, it is okay. You have A1, which is above, if I call this the x-axis, x-axis, you have A1, and A2 is under the x-axis. Okay, you see that the initial oil drive, A1 is the initial oil drive. This curve is the initial oil drive, and 2 is the free imbibition of the brine. Free imbibition of the brine. The brine drive 3 is the brine drive, and it is very normal since it is water. Okay, don't forget that under the x-axis it is the water saturation. Okay, so at 4 you have the free imbibition of oil. 4 is the free imbibition of oil, which lie on this x-axis. Okay, and 5 is the oil drive. So you will calculate the area A1 and calculate the area A2, and you have to divide A1 by A2 to get the work. A1 over A2 and take the log of the value to get the work done, and that will be the weightability. Okay. Now, several graphs may be given according to the value you have from the field. You will do the same job as explained to calculate. Now let's do a comparison between the amount and the USBM weightability. According to the amount weightability index water ratio, we have if the oil is 0, the neutral is 0, and the water weight is greater than 0, then we have water weight reservoir. If the oil weightability is greater than 0, the neutral is 0, and the water weight is 0, then it is an oil reservoir. It goes without saying. But in case, just in case, that it is in between -1 and to -0.3, this is according to the amount since, and the neutral weight is between 0.3 to -0.3 to 0.3, and the water weight is 0.3 to 0.1. The USBM weightability index is pretty different. You can see in the table. You will go through the table and ask all your questions in case you don't understand something. So pay attention to this table, especially when you are working in the lab. Now, the effect of weightability on the electrical properties. The measurements of electrical resistivity of oil reservoirs are commonly used to estimate other properties of reservoirs, such as the porosity, the hydrocarbons reservoir. And it is obtained from electrical logging based on Achilles' law. For those who are into drilling or exploration, the Achilles law, which is an empirical correlation of electrical resistivity index and its brine saturation, and it's always given as Ri is Rs over Rw, which is 1 over water saturation power n minus 1. You have it from this graph. I think we will not spend the time now explaining the resistivity curve, or resistivity versus the brine saturation, which you all saw it in exploration engineering. But nevertheless, we can still explain. Okay. This is a log. This is a log paper where you get the resistivity on the y-axis and the brine saturation on the x-axis. The line, which is the bold line, is the water weight reservoir. The neutral weight is the dot, and where you have the dot a bit bold is the oil weight. So we get the intersection in between both and get our value. Okay, the alteration of weightability, shifting the weightability of the rock from oil weight to water weight by thermal method. We can do thermal method. If the reservoir is oil weight, we can shift its weightability to a water weight to produce the reservoir either by thermal method, by water flooding, or the tertiary production techniques from liquid weight to gas weight. We can also do that. Okay, thank you very much. I hope you have enjoyed this presentation, and I hope I am waiting to see you again in the following or the next courses, the next topic that we are going to talk about in the reservoir engineering. Uh, Before we get to the end, I would like to thank the Bridge Training College and all the techniques and all the staff and team of the college who are helping us and also who have put on this platform to help everybody. Thank you very much. See you again. Goodbye. Thank you.